The topic for the day is differentiation. Now before we begin, we should understand that we are dealing with functions, which is denoted as f of x equals x squared as an example, which has the same meaning as writing y equals x squared. So they are just the same. And the notations for derivatives. The derivatives are also called the gradient functions, which are denoted by f dash of x, or you can say dy over dx, and it's also denoted as y dash. So these are the ways or the different forms in which you can expect the derivatives being asked in a question, or they can even ask you to find the gradient function, which all means the same. And you should also realize that, for example, if I say f of x is equal to 2x plus 1, then f of 1 is equal to 2 times 1 plus 1. In place of x, you replace with the value given, and this is going to be 3. So these are some basic skills that you should know before learning this topic. Another thing that you should understand is, for example, considering the straight line equation 2x plus 3, where m stands for the gradient here, which is the value 2, and 3 is the y-intercept. Now in this case, if you know that x comma y, a coordinate is defined as 3 comma, you don't know what is the y coordinate, and if you know the straight line equation, you can just replace this x with the value 3. Okay, so y is going to be 2 times 3 plus 3, giving you a 6 plus 3, which is 9, which means the y coordinate on the straight line having an x coordinate 3 will be 9. So these are some prior knowledge you need to have. The key topics included in this video will be: first, finding the derivative or the gradient function; number 2, finding the gradient at a given coordinate; and number 3 will be finding the coordinate when the gradient is given to you. In the first topic, finding the derivative or the gradient function, you should be knowing the basic rules of differentiation. For example, if a function f of x is equal to x cubed, then the gradient function f dash of x is equal to 3x squared. Now let me give you another example where f of x is equal to x to the power 5. Then f dash of x is equal to 5 multiplied by x to the power of 4. So from these examples, what do you understand? The rule is that if you have x to the power of n, f of x is equal to x to the power of n, then f dash of x, which is the first derivative, will be n multiplied by x to the power of n minus 1. So this is the key rule or the basic knowledge that you need before learning how to solve the questions. This is one important formula, as differentiation is an introduction to calculus at this point or at this level where you're learning it. Now what if you have f of x is equal to 3x to the power 3? So in this case, you already have a 3 that accompanies x to the power 3. So f dash of x is going to be 3 multiplied by, as we know what is to be done here, so this is going to be 3x to the power 2. So the answer here will be 9x squared. Now let me give you another example where f of x is equal to 22x to the power 10. Then f dash of x will be equal to 22 multiplied by, applying the rule to x to the power 10, it's going to be 10 x to the power 10 minus 1, which is 9. And your answer will be 220 x to the power 9. Taking you to what if f of x is equal to 1 over x to the power 3. So in this case, you should know that 1 over x to the power 3 can be written as x to the power of minus 3. So when you shift from the denominator to the numerator or from the numerator to the denominator, the sign of the power changes. So here it is positive. When you shift it to the numerator, it becomes a negative 3. So my f of x is going to be x to the power minus 3, and I'm going to apply the same rule. So f dash of x is going to be, you multiply with the power which is negative 3, x to the power of minus 3 minus 1. You are reducing the power here. In the previous cases it was positive, so you got a positive power back. Here it's a negative term. So be careful, it's going to be negative 3 x to the power minus 4. Let's take another example. If f of x is equal to 1 over 2x to the power 5, so I can rewrite it first as f of x is equal to 1 over 2 times x to the power minus 5. I'm just shifting this x to the power 5 from the denominator to the numerator. Please make sure that you change the sign from positive to negative. So f dash of x is going to be equal to 1 over 2 times, multiply by the power which is negative 5, times x to the power of minus 6. Now why is it minus 6? Because it's minus 5 minus 1, which is giving you negative 6. Let us look at another example where you have f of x is equal to 3x cubed minus 4x squared plus 6x minus 1. In this case, you're going to apply the rule separately to each of these terms and you get the final answer. F dash of x is equal to 3 multiplied by 3x squared. So this is the 3 which is already here, and x cubed is going to be 3x squared. Minus 4 multiplied by x squared is going to be 2x to the power 2 minus 1, which is 1, plus 6x is going to be 6 times. Now you should understand that x to the power 1, so it's 1, and anything to the power of 0. Why is it 0 here? Because it's 1 minus 1, so it's a 0 here. And here it's a constant, so you don't have anything there. The derivative of a constant is 0, so just for your information, I will put a 0 here to show you that the derivative of a constant is 0. Now your answer will be 9x squared minus 8x plus 6. A quick summary of what we have learned now. F of x equals x, then f dash of x is going to be 1. F of x equals a constant, let it be 7. Then f dash of x is equal to 0. There is no x, so no change. F of x is equal to ax to the power n. Then f dash of x is equal to a times n times x to the power n minus 1. Considering a linear equation y equals mx plus c, if you take the derivative, which is dy by dx, you can see that here it is x, so the derivative of x is 1, and what is left is just m because the derivative of a constant is 0. So in that case, which is pretty right to say that the first derivative gives the gradient of the function. If you want to see, let me put it in numbers, 2x plus 7, so dy by dx is going to be 2, which is the gradient which you have learned in the previous lessons from the straight line equations. Now solving this question to find the gradient. The figure below shows the graphs of functions f of x, f1 of x and f2 of x. You have the two functions. You can see this is a linear function which is given by the straight line, and you have a parabola which is given by this quadratic function. Differentiate f1 of x with respect to x, which means they're asking you to find dy by dx. Or you can say f1 dash of x. So for the function f1 of x equal to x, your f1 dash of x, which is the first derivative, will be 1. And for the second function f2 of x, which is 5 minus x squared, you have f2 dash of x equal to, this is a constant, so minus 2x to the power 1. We can just write minus 2x. The second part is finding the gradient at a given coordinate. Now here is a question where f of x is equal to 3x squared minus 3x plus 2. Find the gradient of the curve y equals f of x when x is equal to 3 and when x is equal to minus 4. So what does it mean? Now you can see it's a quadratic function that you have, and when you plot it you get a curve like this. And you can see at each point or at each coordinate, when you draw the tangent, they have different gradients at each point. I'm just drawing a freehand drawing, but tangents should be drawn with a ruler. Now to find the gradient of the curve, the step 1 here is to find f dash of x, which is 3 multiplied by 2x minus 3 here. So let me just write it as f of x equals 6x minus 3. Now your function that defines the gradient is ready. That means for each coordinate of x, you can find the gradient at that particular point. Now the gradient when x is 3 will be f dash of x equals 3, which is 6 times 3 minus 3, giving you 18 minus 3, which is 15. So 6 times negative 4 minus 3, which is going to be negative 24 minus 3, giving me a negative 27. So this is how the gradient can be calculated if the coordinate is given to you. We have now reached the last topic that will be discussed in this video. Topic 3, which is finding the coordinate when the gradient is given. The question here is find the coordinates of the point on the curve y equals 7 minus 3x minus 2x squared where the gradient is 5. So here they have mentioned the gradient and you have the function. Now before we begin, let me tell you that to solve these kind of questions, you should have an idea about how to solve, or you should have the skill of how to solve a linear equation and to solve a quadratic equation. Starting from the question, y equals 7 minus 3x minus 2x squared. So as a step 1, you have to find dy by dx, which is the gradient function, and here it's going to be negative 3, negative 2 times 2x to the power 1. So this is going to be, dy by dx is going to be equal to negative 3, negative 4x, negative 3 minus 4x. Now from the question, it says that the gradient is 5. So your step 2 will be to equate. In place of dy by dx, you put the value for the gradient, which is 5 equals negative 3 minus 4x. So therefore you can use your own method of rearranging and finding the missing variable, which is x. I will be shifting -3 to the other side, so it becomes a +3, and I'll have 8 equal to -4x. So my x from here is going to be 8 divided by -4, giving me an answer -2. Now you cannot stop there because they have asked you for the coordinates of the point where the curve has this gradient. So if you have found the x coordinate, you have to find the y. And to find the y, you don't have to look for any other way, just substitute it into this equation and find y. So let me do that. Y equals 7 minus 3x minus 2x squared. So y is going to be equal to 7 times -3 times -2 minus 2 times -2 squared. So all that I did is replacing x with -2. Now, two important note here: when you enter -2 into the calculator, make sure you put a bracket like this to square and not just like this. And the second thing is that students tend to put the value for x into the equation for dy by dx again, which is wrong. You go back to the function equation. This is where you substitute. In some cases, if it's given f of x equals this, so again in this equation is where you substitute and not into the f dash of x equation. No. So the answer here is the coordinate is going to be -2, 5. So this is the answer. Solving one more question. The curve y equals x cubed plus 2x squared minus 3x has a gradient of 4 at points A and B. Find the x coordinates of A and B. Step 1. Dy by dx. So 3x squared plus 4x minus 3. The gradient is 4. So step 2 is 4 is equal to 3x squared plus 4x minus 3. By rearranging, you will get 3x squared plus 4x. So minus 3, and shifting this 4 to the side, I have minus 7 equals 0. Now this is a quadratic equation. How to solve it? You can use the quadratic formula or the sum and product method, and you find the value for x. If you're not sure of how to solve the quadratic equation, sharing the link here. You can just watch the video and learn it again. So I'll just quickly solve it here. Now you have found the x coordinates at A and B, assuming this to be the coordinate at A and x equals 1 to be the coordinate at B, the x coordinate at B. And that's what the question has asked you to find, the x coordinate. Now just imagine if you are asked to find the y also, then all that you have to do is put the value for x equals -7/3 into this equation and find y. And you can put x equals 1 into it and find y, so that you have both the x and y coordinates at both these points. So that's it.